We're going to look at 8th grade lesson 1.4, repeating decimal to a fraction conversion. So what we're going to do is we're going to take some repeating decimals and we are going to rewrite them so that they are fractions. And our goal is I can convert a repeating decimal to fraction form. Now before we get started, there's a few terms and a process that I do want to review with you. So we've got some review. First, we need to look at terminating decimal. When I say a terminating decimal, this is a decimal that ends with a remainder of 0. So remember, to go from a fraction to a decimal, we would take top divided by bottom. So let's say 7/8, I would do 7 divided by 8. Eventually that's going to come out to be a remainder of 0. The decimal stops. Now, a repeating decimal is a decimal that continues in a pattern forever. So like 0.123, 123, 123, 123. The same three numbers keep repeating in the exact same order. So that's a repeating decimal. And remember, in order to take a terminating decimal and rewrite it in fraction form, what you do is you take the numbers after the decimal point and they go in the numerator, and then the place value of the last digit goes in the denominator. So here's some examples. Here we have 0.5, or remember, this is tenths. After the decimal point, it's tenths, hundredths, thousandths, 10,000ths. So we would read this also as 5/10. So 5, the number after the decimal point, goes in the numerator, and this is in the tenths place. It ends in the tenths place, so that goes in the denominator. And then we know 5/10 can simplify to 1/2. Now, another example we can look at is 0.127, or 127 thousandths. Tenths, hundredths, thousandths. So 127 goes in the numerator, and this ends again in the thousandths place. So 1,000 goes in the denominator. So this is 127 over 1,000. Now, instead of giving you a step-by-step directions on how to write a repeating decimal in fraction form, it's just going to be a whole lot easier to show you. Now, this is going to get into some math that you've never seen before. It's not necessarily difficult, but you are going to have to do a little bit of thinking here. So just follow along, and remember, we are always going to go over this whenever we get back to class. So here we have 0.7 repeating. So the 7 is repeating. Now, what we want to do is we want to get rid of this repeating 7, because to change this into fraction form, we cannot have that repeating 7. That repeating 7, it doesn't end. And so we can't say, well, this ends in the tenths place. 7/10 is 0.7 by itself. I want 0.7 repeating. So what we're going to have to do is we're going to have to do some subtraction. Okay? Now, we want to set up the subtraction problem to eliminate the 0.7. We're going to do it like this. 1x equals 0.7 repeating, okay, where x is equal to 0.7. So 1 times 0.7 repeating is 0.7 repeating. So that means that 10x is going to be 7.7 repeating. All I've done is I've moved my decimal point 1 place to the right. So 1, move the decimal point 1 place to the right, I get 10. 0.7 repeating, move my decimal point 1 place to the right, I get 7.7 repeating. And I can show you with a calculator. Basically what I've done is I've multiplied this and this both by 10. So I know 1 times 10 is 10. And then 0.7 repeating, okay, I think you get the point. If I multiply that by 10, we get 7.7 repeating. So 10 times x is equal to 7.7 repeating. And we know that whatever I do to one side of the equation, I can do to the other. So I'm not messing anything up. Now that I have this, what I can do is I can set up a subtraction problem. So here's my subtraction problem. Instead of just subtracting the 0.7 and the 7.7, I'm going to subtract the entire equation. So I put the one with the larger numbers, 10x is equal to 7.7 on the top, and I'm going to subtract from that 1x is equal to 0.7. and I'm going to draw my line, which I totally forgot to do before now, so I'm going to draw it now. So there's my line. Now I just subtract like normal. So 10x minus 1x is 9x. The 0.7 repeatings are going to cancel each other out because all these 7s after it, 7, 7, 7, each of those 7s is going to cancel each other out. So what I'm essentially doing is this 7 is gone. This 7 repeating is gone. This 7 repeating is gone. Let's see if I can draw another one. So I'm essentially left with now the problem 7 minus 0. That's 7. Now I have my equation 9x equals 7. Well, this is a one-step equation. You know, if you like drawing the line, draw your line down the middle. Okay, 9x equals 7, so this is times, divide both sides by 9. 7 divided by 9, well, that's the same as the fraction 7/9. And if we go back and we try this on our calculator, remember to go from a fraction to a decimal, top divided by bottom. So 7 divided by 9, I get 0.7 repeating. Ignore that 8 on the end. If you ever go back and check, ignore that. Remember, it rounds up. 7 divided by 9 is 0.7 repeating. So let's look at another one. So here's my second example, 0.2 repeating. Again, I want to get rid of that repeating 2. So I use 1x is equal to 0.2 repeating, and 10x is equal to 2.2 repeating. Because again, if I have 0.2 multiplied by 10, I'm just going to move the decimal point one place to the right. This is just like we've been doing in science. So now I have 10x and 2.2 repeating. So go back, I'm going to set up a subtraction problem just like before. So 10x is equal to 2.2 repeating minus 1x is equal to 0.2 repeating. I've got a funky looking line there. That'll work though. 10 minus 1 is 9x. Again, these two repeatings, they're going to cancel each other out. If I want to, I can mark them out. They cancel each other out. 0.2 repeating is going to cancel out 0.2 repeating when I subtract, leaving just 0. 2 minus 0 is 2. And then divide both sides by 9, and hopefully you figured out we're going to get 2/9. And again, if I wanted to check, 2 divided by 9 equals 0.2 repeating. Now we're going to look at two more examples. They're going to be similar, but there is going to be something a little different in each of those. It's the same basic process. It's just this part, the numbers that we use are going to be different. So here we have 0.74 repeating. Where this time we have two numbers that are repeating, both the 7 and the 4. So I have two numbers that I need to eliminate. If I set this up, 1x is equal to 0.74 repeating, so 10x is equal to 7.4. What I'm going to do is I'm going to end up with 0.4747. I should have actually put a 7 behind that. That's my bad. The 0.474747 is not going to eliminate 0.747474. That's not going to do it. So instead of using 10x, I'm going to use 100x. Move that decimal over 2 times. So 0.74747474, multiply that by 100. So this becomes 100x, and this becomes, move my decimal point 2 places, 74.74747474. So now both of my repeating decimals will be eliminated. I'm going to use the 100x in my equation. And then this part is exactly the same. 100x is equal to 74.74. So I subtract the 1x is equal to 0.74. Notice these line up perfectly. Had I done it differently, it would not have lined up perfectly. So the 0.74, those cancel each other out. 74 minus 0 is 74. 100x minus 1x is 9x, or 99x. So 99x is equal to 74. Divide both sides by 99. And we get 74 over 99. And of course, I have closed out my calculator, so I need to go back and find it. There it is. If I do 74 divided by 99, I get 0.747474, and again, ignore the fact that it's rounding up. Okay, one more. So in this example, 0.16 repeating, where the only number repeating is the 6. Now this one is going to be a little bit trickier because we need to get rid of the 6. So what we're going to do, so that we don't end up with a decimal and a fraction, we're going to do this a little bit differently. 1x is equal to 0.16 repeating. So 10x is going to be 1.6 repeating, and 100x is 16.6 repeating. I'm not going to use the 1x is equal to 1.6 repeating. I don't want to use that. Okay? If I use that, what's going to happen is I'm going to have to subtract 0.6 repeating, and then I'm going to have to do like 0.6 minus 0.1. I'm going to end up with like a decimal in my fraction bar, and then I'm going to have to do a lot of conversions there. I'm going to skip that mess, and I'm going to use these, because if I use 10x equals 1.6 repeating and 100x equals 16.6 repeating, those 0.6's are going to be gone. Everything in the decimal is going to be eliminated. That's what I want to do. So I'm going to use the 10x and the 100x equation. So we've got 100x is equal to 16.6 repeating minus 10x is equal to 1.6 repeating. Notice these 0.6 repeatings, they're lined up perfectly. They're going to eliminate each other. So now I've got 100 minus 10. 100 minus 10 is 90x. And then here, this is slightly different. I've got 16 minus 1. 16 minus 1 is 15. So divide both sides by 90. I get 15 over 90, which can actually simplify to 1/6, because both 15 and 90 can be divided by 15. They end in a 5 or a 0, so it can be divided by 5. That gave me, 3/18, and 3/18. 3 and 18 can both be divided by 3. So again, check. If I take 15 divided by 90, I get the 1 point, and then the 6 is the part that's repeating. So it's a little bit different, but it's the same basic process. Now, if you've got any questions, we are going to go over that tomorrow. We're going to spend a lot of time working on this. This is a little bit different from any math that you've ever done. It's not difficult, it's different.